This is the second video on conditional probability. And remember, when we talk about conditional probability, we use the notation, the probability of A given that B has occurred already. And in this video, we want to talk about a particular concept, and we want to talk about the concept of two events and whether they're independent or whether they're dependent. And we want to talk about this both in terms of kind of an intuitive understanding or common sense understanding, and also a formal definition. So we say that two events are independent if the probability of A is not affected by whether B occurs. And we say two events are dependent if the probability of A is affected or changes by B. And so, for example, let's look at some examples of independent or dependent. So let's roll two coins. Well, you don't roll coins. Let's flip two coins. Okay? And the first is a head. So the question is if the first one is a head, does that affect whether the second one's a head or not? And the idea is that flipping two coins, the two coin flips are independent. Because if you get a head the first time, the probability of getting a head the second time is 50%. But if you get a tail the first time, the probability is also 50%. Let's do this. Let's roll three dice. And the question is, rolling three dice, is that independent? Well, does the roll on one die affect the roll on a different die? And it doesn't, so they're independent as well. Third case, let's roll two dice and add them up. And then in the first one, you can say, what if I roll a 5? Well, that's a different question. There, you're going to roll two dice, and you're going to add up the two numbers. And the question is the total result that you get affected by what you roll the first time? The answer is clearly yes. So those are clearly dependent. And let's look at the problem we looked at before. The probability that you pull a jack, given that you know it's a face card. Right? So you pull some cards, you know it's a face card. Does that change the probability of the jack? It clearly does. In fact, let's look at that example. Right? So let's look at the example, and let's use the card, the same one we did in the last video. So you have you have 52 cards. You have hearts, which is 13, face cards, which are 12, jacks, which are 4. And let's call this event A, event B, and event C. Event A is getting a heart, B is getting a face card, and C is getting jack. Probability of A is 13 out of 52, or 0.25. The probability of face card, 12 out of 52, which is around 23%, not exactly, but around 23%. The probability of getting a jack, 4 out of 52, or about 0.077. And then, if you could think about it, well, let's look at the probability of getting the probability of drawing a heart given that you know it's a face card. Right? Well, then the denominator is face card, so the denominator is 12. And you have to think about how many of the face cards are hearts. Well, let's think about that. You have the jack of hearts, you have the queen of hearts, and you have the king of hearts, so you have 3. So it's 3 out of 12, or 0.25. And if you notice, the probability of getting a heart or getting a heart given that you know it's a face card is exactly the same. And we say that those are independent. Now let's look at the probability of drawing a jack given that you know it's a face card. In our notation, let's find the probability of C given B. The number of face cards is 12. And the number of jacks that are face cards is 4. So that's 0.33. And now let's look. The probability of a jack was 0.23. But the probability of jack, given that it's a face card, is 0.33. And so you notice that it matters. The probability changes when you get a face card. So let's do a definition. We say that if the probability of A given B is equal to the probability of A, that means that A and B are independent. And if you have the probability of A given B is not equal to the probability of A, we say that A and B are dependent. In other words, if knowing that B is going to happen or has happened changes the probabilities, then we know that they're dependent. If they don't change probabilities, they're independent.